Welcome to the Weekly, your source for the trends and innovations we're seeing in the marketplace. So we're 1 week away from daylight savings, 2 weeks away from spring, and then hallelujah, we're out of the winter of 2020, which will be one we will all talk about for the rest of our lives, no matter how young or old we are. Thank goodness it's coming to an end. Our sponsor for today is Modular Building Institute, and they're 100% focused on the expansion of off-site construction, which is a super hot topic and one we've covered many, many times on the Weekly. And they focus on innovative construction practices, on outreach and education, and on recognition of high-quality modular processes, design, and facilities. So check out all their information at modular.org. So we know that COVID's changed everything, and we've done a lot of segments on the design of what buildings look like post-COVID. In our first segment, we look at products and systems. And we have a great expert, Blaine Brownell, who was one of our U40 winners, which means he's smart, walks us through 5 new products and systems he's seeing in the marketplace today.
So we'll jump into Airdoll. So this is essentially a non-toxic silicon dioxide coating that's used as an antiviral ingredient. So why is this important today? And why, as you asked Rob about new materials and coatings, am I interested in something like Airdoll? This past year obviously has changed. It's been a game changer, right? Mm-hmm. It's changed how we work, how we live, how we function in spaces, how we think about surfaces. And I think never before have we been so cognizant of disinfecting our surfaces, right? Thinking about COVID. The problem is that a lot of traditional chemical approaches to disinfecting surfaces and antimicrobial surfaces can lead to superbugs, meaning they can cause resistance and microbes to antibiotics. And we don't want that, because that creates a bigger health concern for humans. So biomimetic approaches look at their ways to modify the natural surface nanogeometry of in a coating with something like silicon dioxide. So it's as if it's tiny particles of glass that, based on their shape, disrupt microbes' ability to propagate and to be viable on a surface. So this non-toxic coating, made in Germany, originally developed for air travel applications, but now available for a wide variety of programs, is dermatologically safe. It disrupts microbes' ability to be viable and to survive on a surface, but it won't cause antibiotic resistance.
And this comes out of a company in Ahrensburg, Germany. They say it's liquid guard technology, and it's actually a spray that creates kind of a glass surface. It's a silica surface.
That's why I love the Weekly. I learn something all the time. This time, it's super bugs, and you have to make sure you're aware of them. And Blaine's ideas around surfaces and lighting and airflow, my goodness, that's everyone's concern as we build and design these post-COVID buildings. Another thing that's accelerating super fast is the integration of artificial intelligence. We look at one for the MEP, for an MEP app. And its goal is to pick the right tool for the right task. Sounds simple? Listen to this.
Since our design engineers are not tasked with designing and drafting and modeling of the wires, pipes, and ducts anymore, they're able to spend more time working with the design team to make sure that the aesthetics and functionality of the spaces are maximized to provide the best user experience. Our team, therefore, has significantly more time to make sure we get all of the layouts right, because they're not concerned with the tasks of designing and sizing the systems. We look at it as using the right tool for the right task, utilize the human's knowledge, training, and experience to make sure we get the aesthetics and function right, and let the computers do what they do best, crunch all those numbers and find the best solution, rather than just a single possible solution that occurs with a human design distribution system. Now, the application of that AI process has a very dramatic impact on the construction and operational cost of the systems it designs. As I mentioned previously, using conventional engineering methods, all you get at the end of the design process is the human engineer's opinion of how to best meet the MEP needs of the space. With the AI for MEP software, you get a thoroughly studied and optimized design that meets all of the parameters set forth for the project at the minimum possible construction costs. The routes are more efficient, the sizing is more accurate, and the design and overall will save the owner money in both construction costs and also the long-term operating and maintenance costs of the building. There's literally less pipe, wire, and duct in the building, so the construction costs are lower and the building consumes less energy for the life of the facility. Mm-hmm. The initial construction costs alone have been proven to provide anywhere from 10 to 37% savings relative to human design systems. We have published a number of case studies wherein these savings are demonstrated versus human design.
That is fascinating, and it makes so much sense. Artificial intelligence crunches all the data and gives you the best solution, rather than taking one person's solution. It just makes sense. So thank you for joining us. A big thank you to our sponsor, Modular Building Institute. If you're thinking about off-site construction, they are a tremendous resource. Check them out at modular.org. If you've missed any of our shows, they're available on Horizon TV or on YouTube. We'll be back next Thursday. Have a wonderful week. Thank you very much for joining us, and be safe. Thanks.